Again, that's why it is a little bit, I tear my hair out when people who are not physicists think, accuse physicists, like you say, of sort of losing the plot because they need dark matter and dark energy. I don't want dark matter and dark energy. I want something much cooler than that. I've tried, but you got to listen to the equations and to the data.
You mentioned 3 papers. Your first awesome paper ever,
Yeah.
and your second awesome paper ever. Of course, you wrote many papers, so you're being very harsh on the others. But
Well, by the way, this is not awesomeness. This is impact.
impact,
Right?
sure.
There's no correlation between awesomeness and impact.
Right.
Some of my best papers fell without a stone.
Tree
and vice
falls in the
versa,
forest.
right?
Yeah.
The first paper was called Limits on a Lorentz Parity Violating Modification of Electromagnetism or Electrodynamics. So we figured out how to violate Lorentz invariance, which is the symmetry underlying relativity. And the important thing is we figured out a way to do it that didn't violate anything else and was experimentally testable. So people love that. The second paper was called Quintessence and the Rest of the World. So quintessence is this dynamical dark energy field. The rest of the world is because I was talking about how the quintessence field would interact with other particles and fields and how to avoid the interactions you don't want. And the third paper was called Is Cosmic Speed Up Due to Gravitational Physics? Something like that. So you see the common theme. I'm taking, what we know, the standard model of particle physics, general relativity, tweaking them in some way, and then trying to fit the data.
And trying to make it so it's experimentally validated.
Ideally, yes, that's right. That's the goal.